You have met a whole zoo of models. Trees, forests, support vector machines, nearest neighbors. They could not be more different inside. So why does the code to use them feel almost identical? That is the quiet genius of scikit-learn. Underneath, scikit-learn gives almost everything the same handful of verbs. Fit, to learn from data. Predict, to make a guess. Transform, to reshape the data. And score, to grade the result. Learn these 4 verbs once, and you can drive nearly every tool in the whole library. Now picture a universal socket. On top, fit. On the bottom, predict. This is the shape of your code, and it never changes. Watch what happens as we swap the model itself. Logistic regression clicks in and scores 0.981. Pull it out. Drop in a random forest. The same 2 lines, fit and predict, 0.956. Swap again. Gradient boosting, 0.963. And K nearest neighbors, 0.965. 4 completely different algorithms, and you only ever changed 1 word. The rest of your code did not move an inch. There is a simple map to it all. Estimators learn with fit. Transformers add transform, like scalars and encoders. Predictors add predict, like classifiers and regressors. And a pipeline simply chains them, so the whole workflow shares the same verbs. The whole philosophy fits in 5 words. Every model is fit, then predict. With this toolkit in hand, we can take on the messier problems. Like, what happens when the thing you care about almost never appears in your data? That is imbalanced data, and it is next.